All right, so here we have another integral of a trig function or combination of trig functions that involves an odd power of one of the functions. So, like I said before, if you see an odd power, what you want to do is break one of those off. So here's what I'm going to do. I'm going to say this is equal to the integral of sine. I'm going to actually write this as sine squared of x squared. Okay, because I know I can replace sine squared, right? And then I have cosine to the fifth. So I can also write that one as cosine squared of x squared. Okay, that's cosine to the fourth. And then I have one more. I have cosine of x dx. Okay, so the idea is I'm going to combine this cosine x dx and do a substitution. So what I'm going to do is, well, actually, before I do that, let's apply the trig identity here to get this sine squared. Let's get rid of this sine squared here. And, actually, so since I have a cosine to pair with my dx, then I want everything in terms of sine. So actually, I'm changing my mind on this one. I'm going to change this back to sine to the fourth of x. Okay, and then I'm going to replace the cosine squared. I'm going to try to replace it with a sine, something involving sine of x, which if I just use the Pythagorean identity, I can replace cosine squared of x with 1 minus sine squared of x. And again, that's squared. Okay, and then I have cosine of x dx. Okay, so now I can do a substitution with w equals sine of x, right? And then my dw becomes cosine of x dx, right? Which is what I have here, so that's good. So now sine of x becomes w, and so I have the integral of w to the fourth times 1 minus w squared, and that whole thing squared, right? Because it's actually cosine squared, or cosine to the fourth, right? Originally. And then I have dw. Okay. Now I can multiply this out because it's a lot easier to integrate a polynomial. So let's just multiply this out. So I'm just going to first of all expand this square. So I'm going to get 1 minus 2w squared plus w to the fourth, right? dw. And then I multiply through by w to the fourth, right? So I have the integral of w to the fourth, and then minus 2w to the sixth plus w to the eighth, right? So I have that whole polynomial, right? And now that's pretty easy to integrate. All right, so I'm going to end up with 1/5 w to the fifth. And then I'll have, so I have the minus 2 times a seventh, so that'll be 2/7, w to the seventh. And then I'm going to have 1/9 w to the ninth plus c. And now I just need to go back and put the sine of x in, right? I have to replace w. So what I'm going to end up with is 1/5 sine to the fifth of x minus 2/7 sine to the seventh of x plus 1/9 sine to the ninth of x. Okay, and then plus c. I think I got everything in there. So that's my final answer right there. So I'm going to put a little box around it to say, there we go, we're done. That's my answer. All right.